In the vast, silent darkness of space, a small but potentially deadly visitor was making its way toward Earth, the asteroid Apophis. Discovered in 2004, it had long been a symbol of both fear and fascination among scientists and the public alike. Named after the ancient Egyptian god of chaos, Apophis was once believed to pose a real risk of colliding with Earth. Over time, calculations ruled out the immediate threat, but its close flyby in 2029 promised a rare and extraordinary scientific opportunity. The European Space Agency, aware of its significance, began planning one of the most ambitious asteroid missions in history, the Ramses mission. The Ramses mission wasn't just another space probe, it was a statement of humanity's growing capability to reach out and study celestial objects that once terrified our ancestors. Designed as a compact, highly intelligent spacecraft, Ramses would rendezvous with Apophis months before its approach to Earth, study its surface, and transmit unprecedented data back to scientists across the globe. ESA's goal wasn't just to observe but to understand how such asteroids evolve, how they interact with Earth's gravity, and whether their trajectories could ever shift dangerously close to our planet. Preparations for Ramses began years in advance. The European Space Operations Center in Darmstadt, Germany, became the mission's beating heart. Inside, teams of engineers, astrophysicists, and mission planners worked tirelessly to ensure that every component would perform flawlessly. Ramses was designed to be lightweight yet durable, equipped with cutting-edge sensors, spectrometers, cameras, and a robotic arm capable of collecting samples. It would orbit Apophis as the asteroid passed within 31,000 kilometers of Earth, closer than many satellites. This would be a once-in-a-lifetime moment to watch an asteroid's behavior up close while it was being tugged by Earth's gravity. The mission director, Dr. Sofia Marek, was known for her precision and passion. She had spent her entire career studying near-Earth objects, and Ramses was the culmination of her life's work. She believed Apophis held secrets about the early solar system, material unchanged for billions of years. To her, this wasn't just science, it was archaeology on a cosmic scale. Every grain of dust on Apophis's surface was a time capsule from the dawn of the planets. When launch day finally came, the atmosphere was electric. Journalists filled the press rooms, cameras streamed live feeds to millions of viewers, and the world collectively held its breath. The Ariane 6 rocket stood tall on the launch pad in French Guiana, gleaming under the early morning light. Inside its payload fairing rested Ramses, secured and silent, waiting for ignition. 10, 9, 8, the countdown echoed through the control room. Dr. Marek watched the monitors, her heart pounding. 3, 2, 1, flames erupted, and the rocket thundered skyward, piercing through layers of clouds before disappearing into the upper atmosphere. Cheers erupted in the control center as the launch vehicle flawlessly delivered Ramses into orbit. A few minutes later, the spacecraft separated and began its long journey toward Apophis. Months passed. Ramses traveled millions of kilometers through the void, its solar panels unfolding like wings, drawing power from the sun. Engineers guided it with gentle course corrections, using ion thrusters that emitted faint blue trails of plasma. In the deep silence of space, Ramses became a solitary explorer. Its cameras captured distant starlight, while its instruments calibrated for the most critical encounter of their existence. Then, the day came when Apophis finally appeared as a faint dot in Ramses's cameras. Slowly, that dot grew larger, its irregular shape and rugged surface becoming clearer. The asteroid spun lazily, sunlight casting long shadows across its craters and boulders. Ramses approached cautiously, matching Apophis's rotation and speed until it entered a stable orbit just a few kilometers above the surface. The first data streamed back to Earth, mesmerizing scientists. Apophis's surface was more complex than anyone had imagined, littered with fractured rocks, dust layers, and strange mineral deposits that hinted at a violent past. Ramses's spectrometers detected rare metallic elements, suggesting that Apophis had once been part of a larger body shattered by an ancient collision. As Earth's gravity began influencing the asteroid's motion, Ramses observed minute shifts in its trajectory and rotation. These subtle forces, almost imperceptible to the human eye, were crucial for scientists to understand how gravity could alter an asteroid's orbit, knowledge that could one day save Earth from a potential impact. But Ramses wasn't done. The mission had a daring objective: deploy a small lander onto Apophis's surface. Named Horus, the lander was no larger than a washing machine but packed with technology. Using micro-thrusters, Horus descended from Ramses, its cameras capturing breathtaking images of the asteroid's terrain. Dust rose as it touched down, clinging briefly to the low-gravity environment before settling again. Once on the surface, Horus began drilling small samples, analyzing them on site. Its instruments revealed the presence of carbon-rich compounds, the building blocks of life. For Dr. Marek, this was more than a discovery, it was a glimpse into the origins of organic matter in the solar system. She knew that asteroids like Apophis could have been the couriers that delivered life's ingredients to Earth billions of years ago. As Apophis neared its closest approach to Earth, Ramses continued transmitting stunning visuals, live footage of the blue planet growing brighter in the background. For the first time in history, humanity watched its home world from the surface of a passing asteroid. The view was both humbling and surreal, a reminder of how fragile and beautiful Earth appeared from the cosmic frontier. During the flyby, Apophis came within 31,000 kilometers of Earth, closer than many communication satellites. Its path curved slightly as Earth's gravity tugged it, creating measurable changes in its orbit. Ramses's instruments captured every second of this celestial dance. The data would redefine scientists' understanding of gravitational interactions in near-Earth object dynamics. However, space exploration is never without risk. As Apophis passed its closest point, Ramses encountered a sudden burst of micro-debris, small rocks ejected from the asteroid's surface by tidal forces. One fragment struck Ramses's outer panel, damaging a thermal sensor. The control team back on Earth held their breath as data briefly went dark. Dr. Marek ordered emergency protocols. After tense minutes, Ramses came back online, its system stabilizing. The spacecraft had survived, and its mission continued. After the flyby, Ramses remained in orbit for several more weeks, monitoring Apophis as it receded from Earth. The asteroid's path was now more precise than ever, confirming there would be no impact threats for centuries. Ramses's final act was to deploy a reflective beacon on the surface, a small, durable marker engraved with the ESA insignia and the words, "We studied the bringer of chaos, and found knowledge." Back on Earth, the mission became a global triumph. The Ramses data flooded scientific journals, leading to breakthroughs in asteroid composition, surface dynamics, and orbital physics. Students watched the images with awe, inspired by the courage and curiosity that drove humanity to chase a rock named after chaos itself. The European Space Agency's decision to turn potential danger into discovery was hailed as a turning point in space exploration. Dr. Marek stood in front of a massive screen at ESA headquarters, watching the last transmission from Ramses. The spacecraft, now drifting silently alongside Apophis, continued to beam faint signals across millions of kilometers. "You've done well," she whispered. The mission had exceeded every expectation, and humanity had come one step closer to understanding the mysteries that lie beyond our world. Apophis's flyby became one of the most observed astronomical events in human history. Millions watched live as it streaked across the night sky, a bright, slow-moving point of light visible even to the naked eye. People who had once feared it now marveled at it, knowing that above its rocky surface, a human-made explorer had been watching, measuring, and learning. Years later, Ramses would remain in space, silently orbiting Apophis as a testament to human ingenuity. It would serve as both a guardian and a messenger, carrying the story of a civilization that refused to fear the unknown. Scientists predicted that one day, perhaps centuries later, a new mission might visit Ramses and find it intact, a relic of an age when humanity first reached out to touch chaos and found meaning in its shadows. In the grand scheme of the cosmos, Apophis was just another rock drifting through infinity. But for humankind, it became a mirror, reflecting not just light from the sun, but the brilliance of human curiosity and courage. Through Ramses, the European Space Agency turned a potential harbinger of destruction into a symbol of discovery. And as the asteroid continued its endless journey through the stars, it carried with it the silent message of Earth: we seek to understand, not to fear. From that day onward, Ramses stood as a reminder that the same universe that can threaten us also invites us to explore it. And every close approach, every celestial encounter, is another chance to learn, another step toward mastering our fragile place in the cosmos. Humanity had not only survived the age of Apophis, it had transformed it into one of its greatest triumphs.